Okay, hello everyone, and thank you for joining us today. As you all know, this is our first event for this semester, and we are excited for you to be here. Before we start, let me introduce myself. My name is Zaina, and I'm a sophomore computer science student. And I was chosen by Google to be the DSC lead for this academic year, and I'm excited for all the events that we have been preparing for you. So before we started our event for today, let me go quickly about on Google's Community Code of Conduct. So as a Google Developer Student Club, we are expected to abide by Google's Community Code of Conduct that expects us to behave responsibly. So be excellent to each other, speak up if you see or hear something, practice saying yes and to each other. And of course, we have zero tolerance policy for harassment of any kind. So if you experience harassment of any kind, please feel free to report it to me directly. Okay, so with that being said, and before we start with our event for today, let me remind those of you who have not joined us on our platform to do so now. So I'll be sharing the link to join us on the platform on the chat. And it's important for you to join us on the platform in order to get all the events that we put there. And also, free monthly subscription on Quick Labs will also be shared to members who are on the platform only. So the link in the chat, and you have to just press the join us button and fill the short form that you will see on the website. Okay, so finally, I'd like to tell you to if you're interested to follow us on social media, we are on Instagram, Twitter, YouTube, where this event is also being currently streamed, and you'll see all the recordings of our events there, and also on our email. So yeah, that was everything from my side. And allow me now to introduce our guest speaker for today, Roland. So Roland is a senior computer engineering student at LAU, and he's also a core team member and a former BMW intern. So he's going to tell us more about the Spring Boot platform today and how to get started with it. So thank you, Roland, for joining us today, and I'll hand it over to you.
Thank you, Jana. Hello, I'm gonna share my screen and let me know once you start seeing it. So let me share my screen. Yes. Just someone can let me know if you can see my screen.
Yes, we can see Roland.
Yes, thank you, Michael. So hello guys, so my name is Roland and I'm a senior computer engineering student at LAU, and today I'm gonna talk about how to build your Spring Boot application. So basically in this event, I will be using Java 11. You can also be using Java 8 or Java 16, and I'm also using IntelliJ as an IDE. So before we start, let us introduce what is Spring Boot. So basically, Spring Boot is a Java framework that makes developing web application faster and easier. Spring Boot is also part of something called a Spring framework. It's built on top of it, so it makes it easier to use the preceding technology. And there's something called Spring Cloud that is built on top of Spring Boot. Maybe we can cover this in later events. So once you start building your first Spring Boot application, you will start hearing a lot of something called annotation, and this is how it's represented. So you start seeing something called atlas controller and a lot of annotation, more and more annotations. So basically in this workshop, I will start be tackling a lot of annotation and explain each one and tell you what each one does, and we'll try to cover as much as possible. So I'm gonna start from the beginning, and let us start by how to actually have a Spring Boot application. So there's actually two approaches. First approach, if you're using the official website, spring.io, you'll have this CLI where you can select, for example, the wrapping project, Maven project, Gradle project, use the language, Java, Kotlin, Groovy, and so on. You can also use the Spring Boot version, set the group, artifact name, the packaging, the Java version, I'm using Java 11, and add dependencies if you might use them in your project. Another approach, if you're using IntelliJ, you can actually use the CLI of IntelliJ. Same CLI, you can use the version, the name, the Java version, and you can also add dependencies. So once you have your first Spring Boot application, basically this is what you will see. And this is the default packaging of a Spring Boot app. So mainly we'll be focusing what's under the source directory and what's the pom.xml. And if I extend the source directory, you can see that there's two main folders, one called main and the second called test. Basically, in the test folder, you write your unit test, integration test, and so on. But I will not be covering any unit testing in this workshop. And under the main directory, you'll have two main other directories, one called resources that has application.properties, and the default Java class, which is called my first Spring Boot application. So let's navigate this file and try to see what's actually written in this file. So basically, the first annotation that we will see today is something called a Spring Boot application. This is how we define a Spring Boot app. So it's a normal Java class where it has the main method, public static void main, and you will add this simple method that's called spring application.run. Select, name your project name, and this is how you have a Spring Boot application running. So in the pom.xml, basically this is what wraps your project. So if you look at the header, you can see that we're using pom.xml, the Maven project version 4. You can see the version, name, description, and so on. You can also see the Java version, but mainly we'll be focusing on this part. So basically the dependencies is where you inject and add dependencies and libraries that you might use. So by default, you will have the Spring Boot starter and the Spring Boot starter test. But since we are not using any testing in this event, so we don't actually need this dependency, but this is the default wrapping of the project. So since we're actually developing a backend for a web application, the first thing is to add the library needed to develop a web application. So the first approach, if you already haven't built your project yet, if you remember, there's a button called Add Dependencies. You can add your dependency that is called Spring Web. So if you look here, it's a Spring Web build web application, including RESTful application using Spring MVC, Apache Tomcat as a default embedded server. The second approach, if you're using your IntelliJ CLI, you can also add the dependencies from here. Lastly, the third approach, if you already have your project set up and you need to add an extra dependency, of course, you don't have to create your project again. Simply a simple Google search by saying what the dependencies that you want, you will get the main Maven repository website, where you can see all the versions of your needed dependency. For example, in this one, you can see the version is 5.3.9, and it's being used by 545 people. And if you click on it, you will get this dependency text. It just copy paste it in your pom.xml. So if you look at it, it's basically mean that this is the dependency, this is the group ID, and this is the artifact ID. And if you don't specify a version, it will by default utilizes the latest version of the Spring Boot starter web. So if you run your application, you will have a bunch of logs. Basically, these logs will tell you that your application is running on port 8080, and it's using Tomcat as an embedded server. So let's start by going to localhost 8080, since our application is running there, and see what happens. So basically, you will have this fallback page, which means that your application has no fallback error. And this is something natural because we haven't developed anything on the localhost 8080. So this is a fallback error page. So in order to proceed for building a small Spring Boot application, so I want to set a simple goal. I want to have hello there every time I navigate to localhost 8080/greeting. And this is how it will be outputted on the browser. So localhost 8080/greeting, I will get something called hello there. So, but before jumping into how to actually build this small application, I will start talking about some entities that you might hear once you're developing a Spring Boot application or any backend application. So we start hearing something called a controller, a service, a repo, and so on. And this is what we'll be doing today. So basically, a controller is also known as the presentation layer. It's an interface which exposes the application functionality. So if I have a greeting controller, most likely this controller will be greeting. And this is a very naive example, but it's also a simple example for you to understand. So if I start by following this architecture, so if you look at the main directives that I previously had, so my first Spring Boot application, source, main, com, example, I will create a directory called controllers, and I will create a class called greetingController.java. And if I navigate to this file, it's a normal Java class where you have public class greetingController, and I have initialized a method called greeting that returns a string, which is hello there. So if you look at this class, so okay, I know it's a controller, and you know it's a controller because I've been talking about controllers for the past 2 minutes. But how can the system know that this is a controller? So you start thinking and thinking, how can I make the system know it's a controller? And then you remember you're using Spring Boot. So of course, one of the solution would be is adding a simple annotation. So the @rest controller will tell the system like, hey, this is a controller. But if we want to go back to the goal that we want to have, if we want to return hello there to the browser. So again, what is the solution? It's to use more and more annotation. So basically, @request mapping means that this is the base URL for all the methods in the class, and greeting is the specific URL for this method. So once I go to localhost 8080/greeting, it will go and initialize this specific method that returns hello there to the browser. So this is the simplest Spring Boot application that you can actually develop. Now, if you want to move to a more likely applications that you want to use, and don't worry, I won't be implementing a to-do application, so this is something very common. I will create something called a quote generator application. So basically, I want this app to save quotes from users. And every day, for example, I want to initialize a certain endpoint to get a random motivational quote every day. So one of the requirements is to actually retrieve random quotes, is the ability to post new quotes, and for example, the ability to remove any quotes that I won't need. So I highlighted the last one in red because I've decided to let you implement this on your own, the last endpoint. So I will be talking about the first 2 endpoints, and I will let you implement the last one on your own. So if you want to revise the application structure that we have, so we have user 1, user 2, user 3. They communicate with something called a quote controller using HTTP request. This controller will talk to something called a service, and the service talks to a repo that communicates with the database, maybe save quotes, retrieve quotes, and so on. So before jumping into the actual coding part, let's talk about the database and the quote model. So we want so this is not an event that actually tackles databases, but if you think about it, if you want to have an application that saves the quotes, I don't want every time I shut down my application to have all the data removed. So I want to store the quote somewhere in a database. So if some of you already have experience in database, you don't have to worry if I'm using Mongo, MySQL, Postgres, or so on. But in this specific event, I'm using Postgres. There is no specific reason behind it. The key thing that I want you to know is that what is this quote database is used for. So I have a quote, I want to save it in the database. So how can I save it, and what properties should the quote object or the quote model should have? So let's give a simpler example. So I'm an LEU student, and in 2017, I registered in LEU. So I provided my first name, last name, major, and so on, but I didn't provide an ID or an email. So the ID and the email was generated by the university by itself. So my ID looks something like 2017 because 2017, it's the year that I registered, and a bunch of digits that make my ID unique. So the same thing for the quote model. If I want to save a quote in the database, it should have a unique ID that it makes them identifiable by any quotes existing in the database. Then it should have something like a text, for example, what's the text of the quote, and let's add another property, which is the author of the quote. So if we want to create this object, we basically go to create a directory called models, and let's create something called a quote object. And to get this out of the way, these are used by adding a dependencies called lombok. So basically the add setter, add getter, add no art constructor, add all art constructor, basically implement all the setters and all the getters, all the art constructor and no art constructor for the class without having to implement them. So this is a quicker way to implement things in Java. And the UID basically looks something like the following. So it's something generated randomly, and there's a very, very few chance to have two IDs similar. So now I have the object. I know how the object looks like and how to save it to the database, but I don't have connection with the database. And even if I have connection, I still haven't told my system how to save and retrieve code from the database. So let's start by first establishing connection with the database. The first step is to add, of course, the required libraries to the pom.xml. And the second step to finally actually use the application.property file under the resources folder. So as I mentioned before, I'm using Postgres. So I have to add the dependency of Postgres, and this is how it looks like. And I'm using something called Spring Boot Starters Data JPA, which very simplifies things and makes the user retrieve and save data into the database without actually having to write their own queries. Now, if we add these dependencies and run our application, the app will directly complain and it will throw an error. And basically this error is the following. Failed to configure a data source. URL attribute is not specified and no embedded data source could be configured. So our application sees that there's a dependency for Postgres and dependency for data, JPA. So it knows that it should be connected to a database, but I'm not telling my application where the database is actually at. So this is why it's complaining. And here comes the role of the application with properties. So basically, the first property, spring.datasource.url, will tell my application where the database is actually at. So I'm using Postgres, so I have Postgres SQL. If I'm using MySQL, it have MySQL. If I'm using Mongo, it will be Mongo. It will have, the next will be localhost because my instance is on my local machine. If I'm using Google Platform, it will be something where my instance is actually deployed and the port, of course. And the name of my database is actually called CodeDB. And in Postgres, you have to also set the user and the password. So of course, if you're actually deploying this application to real production, you won't have your password and a username like in text. You'll have to encrypt them. And finally, the spring.jpa hibernate property, create and drop, basically means that every time I run my application, it will drop the database and create a new database. So of course, again, if you are in production, you don't want on every restart of your application to lose all your data. But since we are developing a simple application, we can have this create and drop for testing purposes. So if you go back and run your application, you'll have a bunch of more logs. Basically, these logs mean that, okay, your application is running and it's also connected to the database that you specified. So now if I go back to the simple class that I have, okay, we already agreed that we have a quote object and it has a unique ID called ID. It has a text and a name, and the name is the author's name. How can I tell the system that, okay, this is the object that I want to save in the database? So I'm using Spring Boot. So most likely I'll be adding a new entity, a new annotation, which is add entity. But if you do that, it will directly complain and it will tell you that persistent entity quote should have a primary key. And this is because in relational tables, databases, you can't have an object saved in your database without a primary key. So to do that, you just add @id above the selected property. And now you have an object that is ready to be saved in your database once you launch your application. And indeed, once you launch your application again, you will see the following two logs. So the 6 lines, I guess, it's hibernate, drop table if exists, because I already said create and drop property rule. And this is what's important to me is that hibernate will tell you that, okay, create table quote, ID, the type of it, UUID, and it's not null because you can't have a unique ID null. You will have a name, varchar 255, basically this is the size of your string, a text, and the primary key, which is the ID and in the beginning of the sentence. And this is how it looks like. It will look like on your database. So it's an object that is mapped to a table and the properties of the table of the class or the attribute of the code table. So this is the ID. It has a yellow key, and you have the following property, name and text. So now, this is how your application looks like. This is the full application. So I wanted to make sure that this is how it looks like from the directory folders, and this is the architecture that we're trying to accomplish. So you have the code controller, the code service, and the code repo. And since we have our model ready, let's start from top to bottom, which is by starting by using the code controller. So I navigate to the directory controllers. I create a new directory called code, and I create a new class, Java class called code controller. And you already know how it will look like. So it's a REST controller because it's a code controller. The request mapping is /quotes. You can name it whatever you want, but it makes sense to be quotes since this controller, its sole job to retrieve and save quotes. And you'll have this simple method annotated by add post mapping. So add post mapping basically means that this method will not consume resources, it will provide resources, because this I will start by implementing the endpoint that add quotes to our database. So I'm posting stuff to my database. And this is how it will looks like, public void create quote. So now if you think of it, just leave Spring Boot aside and think of it as a Java function. So if you want to have a Java function and you have to pass it a parameter, so you pass it a parameter string, you will say that this expects a string and you name the string, for example, TXC or something. So this is the same concept. So the create quote will expect a quote object, and this quote object will be modeled, then saved into the database. So we'll start by implementing the object that we want to receive in this create quote. One thing additional in Spring Boot is that you have to add one annotation that is called @request_body. So this basically means that the object that this method is expecting, it's coming from outside and not from the inside of the source code. So the object that I'm going to be creating is code API request, and code API request will have a string called text and string called name. And I will explain why it does not have the property ID as in the model code. So if I go back to this class, it will have the following header. So public void create quote. It's expecting something from the outside. Its type, it's a code API request that I just created, and I'll just name it request for the sake of the presentation. So it's just a request. So now if you take a step back and think about the code database. So what am I really saving in the database? Am I saving the code model or the code API request? So if I go back to the LEU example, LEU student example. So my name is Roland and my last name is Saloum, and I'm gonna apply to LEU as a computer engineering student. So I go to the registrar and tell them or tell them that this is my name and this is my last name. I want to be a COE computer engineering student at your university. They will tell me, okay, but I won't tell them that I want this ID. The ID is actually generated in the university. And this is the same case here. So I will tell them that I want to have this text and this author name for this quote API request. The system will take this request and create a new object that has the same text from the request, the same name from the request, but a generated ID, which is a UUID in our case, generated inside of the system. Once this is accomplished, the next step is to actually save this object in our database. If I go back to the code controller, you can see that I added 2 extra lines and the helper method. So the code API request will be given to a helper method called get quote model from request, and it's expecting something called a quote API request named request. And this is what's known by a builder pattern. You can actually use a normal constructor. So this method will return the quote model, and this quote model will have the name of the request name, and it will have the text of the request text. So if I'm gonna read this out loud. So return code builder. Dot name, the name of this object, comes from the request.getName, and the text of this object comes from the request.getText. I build the object and I return it to the main method, which is create quote. So now I've accomplished a bunch in the quote controller. Let us talk about the quote service. And let's move this down. We said that we have a quote controller and it communicates with the quote service. Then the quote service communicates with the quote repo and it will talk to the database and return the answer. So basically, if you want to implement this quote service, we'll start by, and this is for having a neat code. There's no need to actually implement an interface, but we'll have to implement an interface called iQuoteService. The I stands for interface, and create the class quoteService and annotate it as addService and implement the iQuoteService. So now if I go back to the class, which is the quote controller. So if we're actually implementing a normal Java application and we want to utilize a class inside of another class, how can you achieve that? It's simply by creating an instance of the class and initializing this class inside of the constructor. Same concept. So the first thing is that I create a private quote service, and this is the service object. I create a constructor for this class, which is public quote controller, and the quote service will be implemented inside of the constructor, and by simply adding @AutoWire. So if you notice here that there's no need to say this quote service equal the new keyword new quote service. By simply adding @AutoWire, it will simply does the job. Finally, and create quote object class, and the create quote method, you will use the quote service because we're communicating from top to bottom, and we will say that, okay, create the quote. And of course, the IDE would directly complain because it will tell you that, hey, the create quote is something that's not been initialized in the service. So you need to jump back into the quote service and actually implement this method. So public class quote service implements iQuoteService, and you annotate it as @service as previously done. And let's create the method that we want. So public void create quote, it will receive the quote model that we already have. And in this step, this is where we're gonna create the ID. So because the service layer contains all the business logic. So you won't create the ID inside of the controller. We create the ID in the service where it actually handles all the business logic that you want to accomplish in your application. So of course, in like more complex app, you will have maybe different methods here, different queries, different logic. But in our case, this is a very simple application. We only want to generate an ID inside of the service layer. So UUID, quote UUID, it's equal to UUID.random UUID. So it's a method that already exists in the UUID library. What's basically mean by its name, it will create a random ID. Then the quote object that I have, I will set the ID to the ID generated from the previous method, and I will have to save in the database. But before jumping and saving into the database, you remember that you have one extra step. This step is that the quote repo is the layer that talks to the database and not the quote service. So we'll have to create the quote repo, then come back to this class. So again, and notice how the directory looks like. So the controller, service, and repo. We create a directory called quote, and we create an interface called quote repository that extends JPA repo. And this is very, very, very important. So this is where JPA dependency start simplifying your life. So basically, it extends this JPA repo that's already been implemented by the Spring Boot developers, and it will take two parameters. So the model that I want to save, which is the quote, and its primary key. So in our case, we want to save the quote model, and its primary key is something called a UUID. And this is all you have to do. So if you come back to this class, simply you need to again initialize the quote repo, initialize a constructor for this class, and say that, okay, this is private quote repository, and this is where I'm gonna initialize it inside of the constructor, and I will add the @AutoWired annotation, and I will add this simple method, which is quote repo.save that takes as parameter the quote model. So I didn't highlight it in red for a very specific reason, is that because even though the method is not implemented by me, the JPA repository has a set of queries which are trivial that already been implemented by the developers of this library. So basically, if I want to save an object, it will directly save the object without having to write the own query or my own method. If I want to fetch, delete, get by ID, even get by name, these queries that are most likely to be used are already been implemented to simplify your life and not have to reinvent the wheel for that. So the quote repository.save will take this model, and this model will be saved to our database. So if you want to have like a general overview of what happened so far, is that I had a quote API request. This API request has a text, had a name. This request was moved to the controller. In this part, we transform our request to something called a quote model. The quote model has the text and the name of the quote API request. In the service layer, we generated a unique ID to this quote model, and we added this ID to the quote model object. Then we passed this model to our database and to our repo, and the repo in this layer, we actually saved the object in our database. So this is what is called a three-tier architecture. And this is one of the, this is one famous and simple architecture to impose once you're building something similar to a backend application. So now if I go back to this huge code, so basically you've seen this before, I just added some extra steps. So basically, let me add the pointers. I'm gonna be looking up because, okay. So this is the quote controller. I initialize the quote service here, the quote service inside of the constructor, and I simply added just something very basic, which is a try and catch. So once I move this model to the service, and this service, for example, will move it to the repo and save it, if these steps were successful, I will return something called HTTP status.created, which is a 202 response. And I will tell my system, okay, the code was created. If I fail, I will return something called an internet server error, and I will return the message behind this error. So this is what I just added in this section. And to test our API, so instead of using Angular or React or Postman or to test our endpoint, there's something called Swagger, which is an interface to test our endpoints. So basically, you can see that I have a post endpoint, which is dash quote, and I have the request buttons I'm expecting. So if you remember, we have a name and a text, which are both strings. So when I press execute, I will pass this request to the controller, and it will pass to the service, repo get saved, and get back the response. If it was a success, I will get created. If it was an error, I will get the error behind of it. So basically, in this slide, I have initialized the ability to post new quotes, and the ability to retrieve random quotes. I will do that live because I know some of you might be confused, and I might be talking a bit in a faster pace. So I'm gonna take my time to actually implement the ability to retrieve random quotes. Just let me share my screen, my IDE. So can someone please confirm that you can see my IDE? Because
yes,
I can't
you can see it.
Okay, perfect. So basically, this is what we have done previously, and we want now to have an endpoint basically that tells us once we init this method, we want to get a random quote. So we'll start by implementing this method. So I want to get something from the system. I don't want to post something to the system. So I will utilize something called a get mapping because I'm consuming resources. And let's say it's a public response entity, which is the entity that I return. Let's name this method get random quote. And it will complain because I haven't returned anything. So let me copy this try and catch and remove these. Now I'm in the controller level. So before that, I've skipped something. So I want to have, every time I go to localhost 8080/quotes, and the quote comes from this base URL /random, I want to initialize this method. So I have to add -random here. Every time I go to localhost 8080/quotes/random, this method will be initialized. So now I'm inside of the controller, and as we've seen before, the controller will speak to the service. I'll start by using this service. So I already created this service by saying quote service, and I want this quote service to get me a random quote. So if it wants to get me a random quote, of course, this method will return a quote object. Let's say it's a random quote that is returned. And please make sure, please that random quote and this get random quote are not the same. So I'm just using this following a convention that so for example, this can get random quote, it's the function in this class, and there's another function called get random quote inside of the quote service. So now it will complain because cannot resolve the method. I haven't implemented this method yet. So if I use some short keys in the IDE, it will take me to the service and it will create the header of the method. And if I go to the interface, it will complain because if you have a class that is implementing an interface, it has to have implemented all of its method or have this method as an abstract. So if I want to write this method here, and I'm inside of the service, so we know that the service will talk to the repo. So I'm inside of the service class. So basically, I will tell that quote repository dot get random quote. However, this time it will complain because the developers of the APA library never assumed that I want to get a random entry from our database. So this is something very, very specific. So I have to actually write its own method and write the query behind it. But let me show you if it's not something specific. So if I use the method that already been done, so I can save, delete all, delete by ID, delete in batch, I can find all and so on. But I don't want to use any of these. I want to get a random quote. And the output of this method, I want to return it back to the service. So I'll just return the answer of it. And let's create finally this method inside of our repo. So basically, since this method is or it's not been implemented before, so this is something I want to implement from scratch, I have to write my own query. So you have to actually know how to write a Postgres syntax. So I'm gonna write this and explain it. So you have to add an entity called @query, and you have to add another property called native true, so it can initialize this query. So basically, you say select star from the quote table, order by, and there's a method called random, limit 1. So basically, if I go back here, the quote controller will call the quote service. The quote service will call the quote repo. The quote repo will call this query inside of the database. It will get the result back, send it back to the service, and the service send it back to the controller, and the controller will finally send the final response. So now I guess this is done, and we can actually test this. Let's try to run our application. Okay, so basically this is telling us that our application is running. The table has been created, and my first Spring Boot application is now running. So if I go to localhost 8080 /swagger UI/HTML, and these are the two endpoints that I created. The first one was from the slide, and the second one I just did. So before actually trying to retrieve quotes, let's start by adding some quotes. So I'm gonna navigate to Google and say motivational quotes, and let's get some motivation quotes. So let's start by, okay, for example, all our dreams come true if you have the courage to pursue them. So let's start by adding the text and Walt Disney was the author of this quote. And if you press execute, you can see created. So basically this created comes from here. So if you notice that I'm returning a status created and a message called created. So it's created, and it's a 201. I guess I said previously it's a 202. So this is what it returns. And let's add another message, for example, this one. And it's Michael Jordan. Okay. So this is also created, and let's finally add a third one, just to have like the random code generator working properly, so we don't have a 50-50 chance. The secret of getting ahead is getting started. Okay, one. And let's execute, and we'll have a set created. So now, if I go back to getting random quote, let's start by getting one random quote. I forgot to actually do something. And this is the quote repo. This is a quote endpoint, and I have to return the random quote, not created. So I have to return the object. And since I'm using a create and drop, it will basically drop all the data that I'm using. So basically I have to do this again. So I'm gonna do this much faster this time. So basically in this folder, if I go to resources, I can set this as create or update, not create and drop, but it's okay now. So let's say, okay, I want to do this query again. It's created, and let's say work hard, play hard by, I don't know, by X. Now, if I want to retrieve our random quotes, we will have work hard, play hard. This has been picked randomly, and it has the ID that is generated by the system. So if you notice here, I haven't told the system I want this unique ID to be to this quote. It's something generated by the system. And if I execute again, so it's 50-50 chance. Okay, we got it from the first time. We got another random quote, which is the secret of getting ahead is getting started. Mark, I don't know his last name. This is Swagger is basically to test our endpoint. We could have simply went to localhost quotes random, and we got similar results. So if I go here, I will get this one. If I refresh, if I keep refreshing, it's a 50-50 chance. Okay, the chances is against us, I guess. Okay, I got now my random quote, which is work hard, play hard. And I guess this is the end of our presentation. Thank you for listening. And I have mentioned the GitHub link. So we can go ahead and forward this repo and try to implement the delete endpoint. And you can just try to merge it to this repo, and I will check it and give you feedback about it. Thank you for listening. Thank you for attending. And thank you, Zena and the core members, for making this presentation happen.
Thank you, Roland, for this amazing presentation, and thank you all for joining us today. Feel free to check the GitHub link that Roland will be posting on the chat, or in case you want to check out the code behind this. And thank you again for joining us today, and looking forward to seeing you in our next events.
I guess we finished earlier, so guys, if you have any question, I can like go back and explain in case.